Hello everyone, welcome to the series of lectures of Thermodynamics, and in today we are going to discuss about the concept called equilibrium. Equilibrium generally requires all the properties of a system that is uniform throughout the system. That is, system will not be having any changes with respect to the surroundings, then we call it as equilibrium. So, and generally, for example, if we have taken the system like this, so if there is no energy interaction inside the system or the energy interaction from the system, this might be any of the interactions, that is mechanical interaction, electrical interaction, thermal interaction. If any of the interaction is not happening, then we can call it as the system. This system will be in equilibrium. So finally, if we want to define the equilibrium, a system is said to be equilibrium state if its properties will not change without any effect with the surroundings. Finally, and we have, there are equilibrium of the system is categorized into four types. First one is mechanical equilibrium, chemical, phase, thermal. So we are having four types of equilibriums. So coming to independent types, what is mechanical equilibrium? For example, mechanical equilibrium is nothing but if there is no change in pressure gradient, no change in physical elements like pressure, velocity, etc., etc. If there is no change or no appreciable changes with respect to the system, that is whatever the pressure that we are getting inside. For example, if any cylinder is leaking, why the cylinder will be going to leak its gas? When there is a pressure change that is in from in and out. This is surroundings and this is the system, and system is having huge temperature, huge pressures, and surroundings is having less pressures. And if there is a change in the pressure gradient, then from the system there might be a pressure change that will happen, that the pressure leakage will happen. And if the surroundings are having greater pressure, then the surroundings will give the pressure to the inside environment. So if there is any difference, then we can see the mechanical equilibrium that is going to be disturbed. Otherwise, the system will be in mechanical equilibrium. For example, the second concept, chemical equilibrium. Chemical equilibrium is nothing but if overall room, for example, if I have taken a room, inside the room, if the chemical composition of the molecules, for example, any order is there, one person is standing here and he has sprayed scent to the air from here. So here generally the concentration of scent is more initially, then the chemical equilibrium will be disturbed, and after a certain point of time all the molecules will be evenly disturbed, and finally you won't see, you can see even molecular distributions might happen. So because of even molecular distribution, when this person stands anywhere in the corner of the room, he may smell the same scent or he might not get any scent smell because he is completely preoccupied with the same order. So generally chemical equilibrium is nothing but if there is no change in the chemical composition, then the system is attained into chemical equilibrium. For example, coming to phase equilibrium, if there is no, for example, if we have taken some ice out of a ice box, so and inside if we place in a beaker, some water is present. So water is in a liquid phase and ice will be in the solid phase. So if there is any change in the phases, for example, more than one phases are present inside a system, then this solid will try to become into liquid by dissipating the heat, by absorbing the heat from the surroundings, and liquid might give some heat to the solid and it will dissolve the solid completely. So if there is no phase equilibrium that is being attained, this phenomena will happen. If there is a phase equilibrium that will be attained, then there is no change in the phase. That is, if a single phase is present instead of multi-phase, phase equilibrium will be attained. Same as that, thermal equilibrium. Thermal equilibrium is generally speaking in this context because we are speaking about thermodynamics here. So if there is no temperature gradient, for example, if I have taken two coffee cups and one is hot and next one is cold, this is at 40 degrees centigrade and this is at 80 degrees centigrade. So generally the temperature gradient is there because 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 of temperature gradient. For example, previously I'm having a coffee cup at 40 degree 80 degrees centigrade, one at and another is at 40 degrees centigrade. Because of temperature gradient changes between those two, there will be a exchange of temperature that will be going to happen from this coffee cup to this, and ultimately finally 80 plus 40 120. So finally 60 degrees centigrade will be attained for this coffee cup and 60 degrees for this, if I have considered there is no environmental impact with the system. So this is temperature thermal equilibrium. So basically we are having four types of equilibriums. One is mechanical equilibrium, chemical, phase and thermal. And next, coming to the next concept, what is the governing concept that we are having to understand what is the type of equilibrium that we'll be having? For example, if we take zeroth law of thermodynamics, basically zeroth law of thermodynamics is derived because zeroth law of thermodynamics is also called as law of equilibrium, because it is completely governed based on the equilibrium concept only. For example, how we can define zeroth law? If any substance is there, for example, any substance like X is a substance, Y is another substance, and Z will be another substance. If X is having at some temperature, say 60 degrees centigrade, Y is at 40 degrees centigrade, Z is at 20 degrees centigrade. Even numbers I have taken. So if three are at three different temperatures, that is there is a change in thermal equilibrium. Thermal gradient is disturbed here. Thermal gradient is disturbed. That means there is no sort of equilibrium that is being attained with respect to change in temperature. And because of that, this this 60 degrees centigrade is unsteady, and this will try to give some energy to this 20, and equivalently it will try to give some energy to this. So ultimately, which will be going to come to equilibrium point, because this is having high energy will be transferred to lower energy states, and which will tries to bring into equilibrium. That is, when x is in equilibrium with y, that means 60 plus 40 100 120. So ultimately it will give 20 degrees to this one. So 60 is given 20, plus 20 will happen, and minus 20 will happen. Ultimately, the new xyz becomes x will be 40 degrees centigrade, and y is already at 40 degrees centigrade, and say room temperature is 40 degrees centigrade, and z is now, after reaching 20 degrees from this x, it will reach to 40 degrees centigrade. So x is in thermal equilibrium with y. Equivalently, x is in thermal equilibrium with z. Ultimately, y is in thermal equilibrium with z because 40 even temperatures are there. That is, thermal equilibrium is attained. So zeroth law states that if two systems are in thermal equilibrium with the third system, if two systems, this one is the first system, this one is the second system. If two systems are thermal equilibrium with the third system, then all the three systems will be in thermal equilibrium with each other. So this is zeroth law of thermodynamics. So till today, we have completed this class, and in the next class, we'll be going to discuss the new concept. Thank you.